Hey class, as we get to going today, we're going to be continuing in the chapter 2. You will notice that I have posted a definition sheet for you for chapter 2 in the vocabulary. So we're going to kind of look over that and read over that together. So that way we can get our mind familiar with where we left off. Also, I would like for you to locate the sheet that I hand wrote for you, and then also the packet in which we were graphing last time. So if you'll locate that packet. So as we begin, some of the definitions that we're going to be going over here would be reviewed. So raw data. That's just data collected in the original form. Frequency. That is the number of times a certain value or class of values occurs. So frequency is another name for counts, how many times something occurs. Frequency distribution. That is where you're going to organize the raw data in a table form with classes and frequencies. So a frequency distribution is a table form, and frequency is the time something occurs. So your counts. And in a frequency distribution, you're going to have classes and frequencies. Sometimes you have that extended frequency distribution where you add other categories to the table also. So categorical frequency distribution. That's a frequency distribution in which the data is only nominal or ordinal. That just deals with categories such as names. Ungrouped frequency distribution. That is a frequency distribution of numerical data. The raw data is not grouped. Grouped frequency distribution. A frequency distribution where several numbers are grouped into one class. Class limits. That separates one class in a grouped frequency distribution from another. The limits could actually appear in the data and have gaps between the upper limit of one class and the lower limit of the next. Class boundaries. They separate one class in a grouped frequency distribution from another. The boundaries have one more decimal place than the raw data and therefore do not appear in the data. There is no gap between the upper boundary of one class and the lower boundary of the next class. The lower class boundary is found by subtracting 0.5 units from the lower class limit, and the upper class boundary is found by adding 0.5 units to the upper class limit. So subtracting, and then you have the adding. Class width. That is the difference between the upper and lower boundaries of any class. The class width is also the difference between the lower limits of two consecutive classes or the upper limits of two consecutive classes. It is not the difference between the upper and lower limits of the same class. Class mark or midpoint. That is the number in the middle of the class. It is found by adding the upper and lower limits and dividing by 2. It can also be found by adding the upper and lower class boundaries and dividing by 2. Cumulative frequency. The number of values less than the upper class boundary for the current class. This is a running total of the frequencies. Relative frequency. The frequency divided by the total frequency. This gives the percent of values falling in that class. Histogram. A histogram is a graph which displays the data by using vertical bars of various heights to represent frequencies. The horizontal axis can either be the class boundaries, the class marks, or the class limits. Frequency polygon, a line graph. The frequency is placed along the vertical axis and the class midpoints are placed along the horizontal axis. These points are connected with lines. Ogive, a frequency polygon of the cumulative frequency or the relative cumulative frequency. The vertical axis, the cumulative frequency or relative cumulative frequency. The horizontal axis is the class boundaries. The graph always starts at 0 at the lowest class boundary and will end up at the total frequency for a cumulative frequency, or 1.0 for a relative cumulative frequency. And stem and leaf plot is a data plot which uses part of the data value as the stem and the rest of the data value as the leaf to form groups or classes. This is very useful for sorting data quickly. What I would do is put this to the side, make reference to this vocabulary as you're doing questions if you are unfamiliar with what it is asking, and I'll kind of call that back out throughout the lecture as we're looking. So the first thing we need to do is we need to locate the notes in which we left off with last class. We was constructing, if you remember, we were constructing a histogram, and now we are to the relative frequency histogram. A relative frequency histogram is also going to be a bar graph that represents the frequency distribution of a data set. The vertical scales measure the relative frequencies, not the frequencies. The properties. The horizontal scale will have the class midpoints or the class boundaries. The vertical scale will have the relative frequency. This is the part that is different from the regular histogram. And the consecutive bars are going to touch. Now, on a separate sheet of paper or somewhere on this, you need to add this information to help you as we're kind of reviewing and moving forward. The graph that we left off with was called the histogram. And if you recall, we put the frequencies here on the y-axis. The frequencies was the number of counts. So if you refer back to your definition, the frequency is how many times something occurs that you're counting. Normally, I use class boundaries for the x-axis. You can use class midpoints. If you use the midpoint, that number will go in the middle of the bar. Now, we're going to focus on relative frequency histogram. Now, going back to the definition that we just read about relative frequency, you are going to compare the frequency from each class to the total frequency. This is going to give you a percentage of how much is lying, how much of that data is within that bar. So the formula, you take the frequency and you divide by the total frequencies. Now with this, it gives you a percentage, and you need to leave that percentage as a decimal, okay? When you are putting that relative frequency on your graph, you need to label that with decimals. Okay, so we're going to use this same data that we had a while ago. So I'm going to give you a moment. If you'll go ahead and put in your classes, we're going to locate your class boundaries. Now remember with your class boundaries, and if you ever forget to, you can go back to this sheet. You're going to subtract the 0.5 from your lower class and add your 0.5 to your upper class. So this is where you're going to do plus or minus 0.5. So we're going to subtract the 0.5 here, which would give us a lower class boundary of 41.5. We're going to add the 0.5 to the upper class, which would give us a 50.5. See if you can complete the other two. So this number is going to repeat. And you would notice if I subtracted 0.5 from that, it would be 50.5. I'm going to add 0.5, so that would be 59.5. Subtracting 0.5 is going to give me this again. And adding 0.5 is 68.5. Now the frequencies, I believe we counted those earlier. So if you'll look back, I think those were 8, 17, and 5. Now, your relative frequency. With your relative frequency, you're going to take the class frequency and you're going to divide it by the total frequency. So you're going to take the frequency and divide it by the total frequency. You're going to leave that as a decimal, okay? And that decimal can be converted to a percentage. And it will tell you how much percent is actually falling within that class. Okay, so this would mean we have to have the total frequency. So if you don't know that, you always add up all of your frequencies. And this would be the sum. So the sum of the frequencies should be 30. If you remember, that was the first 30 presidents. So we had 30 ages within that data. If that's not given, again, you would add those up and it would give you a total number. So that is your total frequency. You take your class frequency and you divide by your total frequency. You take your class frequency and divide by your total frequency. And the same here, the class divided by the total. Now you will then convert those to decimals. The first decimal would be 0.26 repeating, or approximately, if I round that, 0.27. 17 divided by 30 would be 0.57 repeating, which is approximately, my bad, that was 0.56 repeating. I was rounding, which is approximately 0.57. And then 5 divided by 30 would be 0.16 repeating, which is approximately 0.17. Now, when you total those, it should give you a whole, because the total of a percentage is 100%. Now, if you round off and you're doing your totals, due to rounding, it's going to be a little bit higher or lower depending on the rounding. So you can see this is about 1/100th of a point off. And that's okay. We're just kind of rounding to get an idea. So it should be approximately 1. So the sum of those should be close to 1 of your relative frequencies. Okay, so what we're going to do next is I just wrote down again what you want to put on your horizontal scale and what you want to put on your vertical scale. Okay, So if I go down here, you want to make sure that you have a title. So this was discussing the age at inauguration of the first 30 presidents, or the age of the first 30 presidents at inauguration. Your relative frequency will be right here, and that's going to be your decimal values. And the age is going to be there, and that's going to be my class boundaries. Now, you have to develop your own scale. I went by 0.05 each time, 500ths. So I'll give you a moment. It should come out to be somewhere about 0.65 at the very tip top. And if you need to pause, just pause that. So I'm going to try to develop this into 3 classes. So 1 would be that one, 2 and 3. So I'm kind of just dividing that out a little bit, trying to make each of the bars equidistant and the same size. If you really want to be perfect at it, get you a ruler. So now I'm going to put the class boundaries. The class boundaries are going to occur at the ends. So this would be 41.5 to 50.5. Then you would have 50.5 to 59.5. And then you would have 59.5 to 68.5. Now notice I have a break in this scale, because if I start at 41.5, then my next number should be adding 41.5, which should be 83. So since I'm not keeping that same pattern from 0, I would have to have a pattern from this point over. So if you notice, 41.5 plus 9 gives you 50.5. 50.5 plus 9 gives you 59.5. And if I add 9 again, I get 68.5. I do not have to break here because I kept that same pattern from 0. So now I'm going by 0.05 each time. So I did not have to break from that point. Okay, now I'm going to look for something kind of close to 0.27. So here's 0.25. Halfway between that, if you need to figure that out, you would just do a midpoint. And that would be about 0.275. So it's just a little bit above that, but it's hard to get exact. So I'm just going to kind of put a little mark right there. Okay. Now my mark's there to tell me how high to go for this bar. And then, of course, I would need to erase that mark. Then I'm just going to color that bar. Okay, the next bar would go to about 0.57. So I'm just going to try to go somewhere in the middle of that. Draw that bar going up, up, and then just connect horizontally. And then your last bar is going to go to 0.17. Okay. I'll try to make that, since I don't have any white out, just kind of go together. But try not to go past that bar. Okay. Now, when you're looking at that, you can look and tell where most of the percentage of the data is lying. So if you look at this bar, you have approximately 27% of the presidents were between those ages. This one would be approximately 57% of the presidents' ages would occur in here, from 51 to 59 or so. And then this one would be approximately 17%. Okay. So when you're trying to think of a pattern, one of the patterns would be more presidents' ages were between the 50.5 and 59.5 class boundaries for their ages. So somewhere between 51 and 59 is where most of the ages fell. Now, if you are doing midpoints and you want to do the midpoint, that has to go in the middle. So the midpoint, if you remember our definition for midpoint, you would take, it works both ways. You can take the two class boundaries and add those up and divide by 2 and get 46. Or you can take, if you recall where we did that one yesterday, you can take the, here we go, the two classes and add those two and divide by 2. So 42 plus 50 divided by 2 gives you that same midpoint. So when we read that definition a while ago, you could find the midpoint with the boundaries or the classes. So you could actually get the midpoint right there between those 42 and 50, and it would give you that 46. So if we look at this one, this midpoint, put it in the middle, was 55. And then the midpoint was 64. So to get the midpoint, sometimes it might be easier to go back to the class where you didn't have the decimal, okay? Just depends. It's going to work either way. So this is my midpoint, and they would go in the middle. You don't have to use both. I like to use the class boundaries. So that's what you'll see me do most, okay? Okay, going to the next portion. The next portion deals with the ogive. Let's go to it next. If that's not the next one in your notes, if you'll just kind of jump ahead to the ogive with me. Now I'm going to read all this out and then we're going to put it together, okay? An ogive is going to be a line graph. So if you recall, the histogram and relative frequency histogram, they were bar graphs. This one's going to be a line. It's going to display the cumulative frequency of each class at the upper class boundary, at its upper class boundary. Now with the ogive, you're going to keep adding frequencies class by class. Now, if you look at the word ogive, put you a note that this graph is going to be open, okay? Ogive open. And what's going to happen to this graph, I'm just going to kind of put it under here for an example. You're going to sometimes have a break here like we did when things don't start in the right pattern and you have a pattern that works after that point. But you always start your ogive at the x-axis, okay? And what happens is you get these segments. And when you get these segments, they're just going to continually to go upward. They might have a different slope, but they're going to continue upward. And then you're going to have a point there in where it ends. So you're always going to start, okay? And then it's going to end somewhere up in the sky because it's open. It's not going to come back down and close, Okay. Now, specify the horizontal and vertical scales. The horizontal scales are going to be the upper class boundaries. So for the horizontal scale, you're going to put the upper class boundaries. So that's going to go on this axis right here. Is going to be your upper class boundaries. The vertical scales is going to be the cumulative frequency. Okay. This is going to be your CF, your cumulative frequency. So where this ends right there at that dot, that's your total frequency. Now remember us discussing what frequency was? That's your total counts. So that's going to be your total frequency. Your upper class boundary is what you're using here. And right here, you're using your cumulative frequencies. Okay. Now you're going to plot the points that represent the upper class boundaries and their cumulative frequencies. So like I mentioned, you're going to plot the points. You're going to begin at the lower boundary of the first class and end at the upper boundary of the last class. And I'm going to explain what that means in just a moment when we look at our graph. Remember, when you have an ogive, it's going to be open, which means it's going to be open because we're going to look at a polygon in a minute, and polygons are closed. Okay, before we move forward, if you'll go ahead and fill this part in with your chart. And I want you to copy this next. So if you need to pause, if I'm moving it too fast, you do need this information or it will help you. This is what I said I was going to come back to. The graph starts at the lower boundary of the first class. Then you're going to use your upper class boundaries. So what that means is you should start at 0 and go up. The highest value ends at the total frequency. Okay, and if you will add horizontal and vertical, upper class, cumulative frequency. Okay, so let's go back and let's think about what our boundaries were. Do you remember where we were adding these over here? We added that 0.5. This is our lower class. When we subtract 0.5, this is our upper class. So our upper class boundaries are going to be the ones where you have added 0.5. That's what you're going to use for your horizontal scale on the ogive. So when I go to this part, when it doesn't give that to you, you need to go ahead and maybe highlight or circle. So you're going to use the 50, the 59, and the 68. And you're going to add the 0.5s to those to get your upper class boundaries. I'm going to remind you how to do the cumulative frequency. So let's go back and get the regular frequency. So looking back, I think those were 8, 17, and 5. So to get the cumulative frequency, you just bring that over because that occurred 8 times. Then you add. So you take that 8, pretend like you've got 8 things to learn from chapter 1 and 17 things to learn from chapter 2 and 5 things to learn from chapter 3. If that test was cumulative, you would add those each time as you're studying those. So then you have 8 plus 17. That gives you 25. Then you have 25 plus 5. That gives you 30. That 30 should be your total frequency. Okay, so now I'm going to go to put the title, Age of the First 30 Presidents at Inauguration. I'm going to have to come up with some scales, okay? So I'm just going to go ahead and put CF here for cumulative frequency. And I'm going to go ahead and put upper class boundaries for the horizontal. And I need to look at that and kind of get an idea of what those things are. So first of all, when I look, I need to do upper class boundaries. So when you do this, do not use this point right here, okay? I want you to space over, space over, space over, okay? We're going to have, for this one, 50.5. For this one, 59.5. And lastly, 68.5. Now, for this was dealing with your ages. So I need to put something about that here. So that's dealing with my ages. Now, notice that I need a point right here, okay? What you have to do to get that point is make sure this stuff is going in the correct pattern. Remember, 0 is there. Each of these we're going by the number 9. So when it says the graph starts at the lower boundary of the first class, all you have to do is remember to take 50.5 and subtract the pattern, which is 9 because you're going backwards. And that would be 41.5. Now, if you want to go back from that and subtract 0.5, you can do that also. Okay? But if you just notice there's a pattern there, you could figure that number out. Okay, now I am going to look at these numbers here. And I'm going to try to come up with a pattern. So if I went by ones, it probably wouldn't be enough. So I'm going to try twos. 2, 4. I'm just going to keep going. $26. So I got up to 26. And I think I got to go to 30, don't I? So 28. I'm going to go up a little bit more and put the 30 right there. Okay, now when you graph, remember that you're putting dots because it's going to be lines, kind of like when you graphed a linear equation in algebra. So you're going to look at your upper class boundary, which is 50.5, and you're going to plot a point at 8. So this is like your X, and this is like your Y. So I'm going to go to 50.5, and I'm going to go up to 8 and put a point. Then I'm going to go to 59.5, and I'm going to go up to 25, between 24 and 26, and put a point. Then I'm going to go to 68.5, and it's going to be all the way up there to 30. Okay. Now, if you recall, okay, let's go back to this. The graph should start at 0 and go up. So whatever this boundary is, whatever this is, this number, you just put a point there. okay? Whatever that number is, when you've counted backwards, you're going to put a point there because it's got to start on this x-axis at 0. Now you're going to connect the segments. And that would be your ogive, okay? The total, which is right here, should be the total frequencies. There'll be some problems and it'll say how many people was in this ogive, what was the total frequency? Well, that total number for that frequency, okay, is going to occur at the tip of that graph. So that's going to be your total frequency, or the word that's used is cumulative frequency. So that's going to be your cumulative frequency because that is your total. That is your total. That's the cumulative frequency from everything, 30 presidents. Okay, ogive open. So let's go now to the polygon. Now, you should know that a polygon is a closed figure, okay? So the ogive starts with an O and it's open. A polygon is going to be closed. So a polygon is a closed figure, okay? So what is a frequency polygon? A line graph that emphasizes the continuous change in frequencies. Use the same horizontal and vertical scales that you would use in a frequency histogram. Remember, histogram's a bar graph. Plot the points that represent the midpoint and the frequency of each class and connect the points. The graph should begin and end on the horizontal axis. The graph should begin and end on the horizontal axis. Now, what that means is, you remember the ogive, it went up, up, something like that, and it stayed open up at the top. With a polygon, you have to bring that back down. So with the polygon, it is going to begin and end on the horizontal axis. So you need to make sure that it is closed, that it is bounded and closed. Okay, so let's take a look at our classes again. Same data, 42 to 50, 51 to 59, and 60 to 68. Okay, take a moment and see if you can get your midpoints. Remember, you're going to add and divide by 2. So to get a midpoint, 42 plus 50 divided by 2. So it's lower class plus upper class divided by 2. So this would be 46, 55, and 64. The frequencies are the same, 8, 17, and 5. Okay, for your horizontal scale and your vertical scale. So horizontal, you want to put your upper for your horizontal scale, excuse me, you want to put your midpoints, yes. I was about to do the ogive again. So you want to do your midpoints. And then for the vertical scale, you want to make sure that you have your frequencies. Now, for this one, you do need to do the midpoints, okay? I know with the other ones, we did the class boundaries, and you could have done the midpoints. That's where it's referring, use the same as you could with the frequency histogram. But if you didn't use midpoints with frequency histogram and use the class boundaries, you need to use midpoints with this one, okay? So don't get confused there. Okay, so let's first of all go ahead and put a 0 right here. And I'm going to put you a note here for the left side that's probably going to be important. Extend the left side to one class width before the first class and extend to the right side one class after the last class midpoint. So you want to extend the left side to one class width before the first class midpoint, and extend to the right side one class after the last class, and make sure you're doing midpoint. So remember, it needs to follow a pattern, okay? It needs to follow a pattern. Now I'm going to put this here for you. I'm going to draw this. Now, when you deal with the frequency polygon, you're going to put frequencies here. And I'm going to put XM here. That stands for midpoint. Okay? That means midpoints. In case I lost anybody. So that's what you're putting on the axes. Okay, so let's go ahead and look at our midpoints. You got to be careful here as you're going through, because remember, we've got to space it over because we're going to have to go back to the left. So we're going to have to extend, we've got to go backwards and forwards, and you'll see in just a minute. So my first midpoint that I have here is 46, okay? So I'm going to space over to about 46. My next midpoint is 55. My next midpoint is 64. Okay, now when I said extend, I'm fixing to show you this. You got to extend to the left and you got to extend to the right. So let's think about what this pattern is, okay? So if you have trouble figuring out the pattern, you can always do reverse, like 64 minus 55. So there's 9 units there. So I take the 64 and I add 9 to go to the right. So this would go out here at 73. Okay. Then I extend to the left. So I'm going to do 46 minus 9, and that's going to go to 37. So I'm going to put 37 somewhere there. Okay. I need to break that because I'm not going 37 each time. I'm going 9 each time. And then if I had a pencil, I would probably go back and erase some of that to make it about the same distance between. Now we're going to go through and we're going to label the y-axis. Now that deals with your frequencies. So the highest frequency is 17. So I think I'm just going to try to go by ones and see how that goes. Okay, so it goes a little bit above, and I just kind of kept numbering. Now, this is going to be my frequencies. That's the number of times that age fell within this group. So this was my ages again. So you're still labeling. Make sure you label all axes. Make sure you put a title, okay? And the title is still going to be the same here. So it's the ages of the 30 presidents at inauguration. So now we're going to plot. So I'm going to go from 46 up to 8. These are going to be dots also. I'm going to go from 55 up to 17. I'm going to go from 64 to 5. And then I'm going to connect those. Okay. This does not look like a polygon. Notice that it is open. Okay. That is why you have to extend one class to the left. Then you have that to connect. And you extend one class to the right. So you have that to connect. Okay. So this was my midpoints. And I'm just going to put you a note for studying. That's your midpoints. We extended one class to the left, so I subtracted 9. According to your pattern is what you would do. I extended one class to the right, so I added 9. Now this figure needs to be closed, which means when you color it, this information is within this polygon. So notice that this is a closed figure. It is made up of the lines, segments, but you're going to have to close that. Okay, so I'm just going to put a note. This needs to be closed. Polygon. Okay, and make sure you have midpoints and extend. Extend left. Extend right. Okay, ogive open, polygon closed. Ogive open, polygon closed. Okay, so for the last portion, I think that it goes into 2.2. 2.2 graphs are not very difficult. The lesson doesn't take very long. You notice this packet is pretty thick. So what you need to do for today is you need to go through, make sure that you're understanding everything that I have taught you based on 2.1, excuse me. 2.2 is very, very short. It is this last page right here, and it's very, very easy. What you might want to do is take a break because it's a lot of information, or you can keep going. But once you have completely finished 2.1 and 2.2 notes, you need to upload those to D2L. Okay? So I'm going to keep going and finish 2.2. But if you need a break, because it's been about 50 minutes, take a break and come back and kind of look back through what I've told you about all this. It's not hard. It just sometimes is time consuming. Okay, so let's take a look at stem and leaf. Stem and leaf, very, very easy. You probably dealt with this sometime in middle school. The stem is going to occur on the left side and the leaf is going to be on the right side. It's a way to display quantitative data graphically in which each data entry is separated into a stem and a leaf. You should have as many leaves as there are entries in the original data set, and the leaves should be single digits. Okay. So this says create a stem and leaf plot using the scores of 24 students in a biology class on a midterm. Now, we don't have to deal with the grouped and ungrouped and all that. So if you want to just kind of mark that out over there, when you do the stem and leaf, it's just going to be this one type where it's going to be grouped and ordered. We don't really do the unordered. So I'm just going to show you with the stem and leaf. You put the stem, I put stem, sorry. You put the stem on the left and the leaf on the right. So if you was to have a number like 3, and then you have a 2 and a 4 and a 5, we're just going to say we have those numbers. The next stem would have to be 4. Maybe that's a 1. Let's say you don't have anything for your 5. And let's say that it goes to 6 and a 0, 3, 5. And then it's going to have a key. The key will be somewhere to tell you how to read it. And you have to put that when you draw yours. So I'm just going to use the first number. 3/2 is 32. So what that means is it's showing me that that would be the number 32. So now I can write the numbers 32, 34, 35, 41. There's not any 50s, but you have to make sure these go in order. Then you have 60, 63, and 65. So these cannot skip. If you have a 3 and a 4 and it goes to 6, these have to go in order. You just don't put anything for the leaf. You have to have a key to represent that. And again, your stem is on the left, your leaf is on the right. So we got a title. This is grades on biology midterm. So I'm going to put stem, leaf. Now what you need to do is you need to go through and you need to get the lowest number. So you want to find your lowest number and your highest number. So my lowest number, it looks like, is 67. My highest number looks like is 95. So that tells me my stem is going to start with 6 and go all the way to 9. So I'm going to have a 6, 7, 8, 9. Then I put these in order, starting with the lowest, and you can see that it increases to your largest. So we have a 67. I would mark it out after I used it. Don't put commas. 68. 73. 75. 75. So we need to put 2 5s. 76. 79. Then we have 1, 2 80s, an 82, see, 83, 85, 85. Looks like there's a lot of 80s. 87, 87, Like a lot of people made a B. That's what I'm observing. 88. Okay. Then we've got a 90. Here's our A's. Okay, more 90s. 91, 91, 91. 3 91s. 92. 94. And it looks like 2 95s. Now I would count these to make sure I had 24. So I got 24. And then I need to put a key. So my key, I'm just going to say is 6/7, which would be 67. And normally you just kind of put that in a box with your key there. And then you would put down whatever pattern you notice. You know, when it comes to patterns, a lot of times there's not a wrong answer. It looks like, in my opinion, most people did very well on the test. I mean, nobody failed it because your lowest grade was a 67. Most people look like they made either an A or a B. So as a teacher, I would look at that and kind of say, well, most people made between an A and a B, so that looks pretty good. So most people have that information pretty well. And C is average, and so there was only really 2 people below average. Okay? Then you have what's called a double stem and leaf. Now, a double stem and leaf gives you a little bit more detailed picture of the data. Now, again, mark out this information like we did a while ago. I'm just going to kind of mark that out. I'm going to put a few notes over here. Just make your little box over there. Okay, again, with a double stem and leaf, you're going to have 2 stems. So that's why it's called double. Put down this. I don't know if you wrote this part down. Double stem and leaf. Okay, so I'm going to look for the lowest value and the highest value in just a minute. But let's talk about what that looks like. So we're going to have our stem and our leaf. Okay, you're going to have, let's just say that we have the number 3. You're going to have those 2 times. Okay, then we're going to have 4. We're going to have that 2 times. We're going to have 5. We're going to have that 2 times. So that's why it's called a double stem. You have the stems in pairs. Now, the leaves come from, if you are kind of like, think about it in terms of rounding. Anything between 0 and 4 would be considered on the first stem. Anything with 5 or above would go on the second stem. So anything 0 to 4 would go on the first one. Anything between 5 and 9 would be on the second. So if the next data point was 45, you would take that to the second stem. You would leave the other blank if there was not any numbers for that, but you still have to put 2 stems. If the next one was 51, goes on the top row. If the following one was 56, it goes on the second row. So the second stem is anything that is 5 or more, okay, 5 or above. Anything less than 5 goes on the first row. So if you think about that in terms of rounding, that might help you. When it's 5 or more, you bump it up. So bump it to the next stem. Okay. So this one says that you have highway fuel consumption. So I'm just going to put highway fuel consumptions. And I'm going to go ahead and put the word stem and leaf. And I'm going to look for my lowest number and my highest number. So I've got a 24. and it looks like a 45. So I'm going to have 2 2s, 2 3s, and 2 4s. And again, you want to put a key, and I always just take the first one. So 3/0 is 30. You can take any number that you want to. Always in a stem and leaf, have a title and have a key. Okay, so we're going to have a 24. That goes on the first row. See the next numbers, 2 25s. Actually, here's another one. So 3 25s. Then you have a 26, 2 28s. And then we go to 30, first row, 30, again, 32, 32, 4, 34. Is that all the 34s? Yes. So I'm going to go to the next row, 35, 30. Do we have any more 35s? I don't see any. So 36, 37, 38, and 39. Okay. 40. 40 again. 40 the third time. 40 again. So we've got another 40. Goodness, 5 times. Okay, then I got a 42. 42. 44. Any more 44s? I don't see any. And then I got a 45 and a 45. I hope I got them all. It's a lot of numbers, so I'd count them. So we need 28. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 2, 3, 4, 5, 6, 7, 8. So I'm going to put a key. 2/4 is equal to 24. And then you can write down whatever pattern you notice about the fuel consumptions with your miles per gallon. Okay? Okay, the last one is your dot plot. Okay, a dot plot is exactly what it says. You're going to have a horizontal line and you're going to put dots above this. So it's kind of like graphing on a number line. Okay, I went by, I went 100, 105, so I kind of tried to find those hash marks that were a little bit darker. And then you would want to give this a title. So this is systolic blood pressure. And it looks like we're dealing with 30 patients. So we're going to have 30 dots. Okay. Now, it doesn't matter where you start here. You just put the dots. So the good thing is you do want to look at your low and your high to figure out like how to number the number line. So you do want to look at that. So I did kind of glance and see that I had 200, which was the highest. So I do need my number line to go to at least 200. And then trying to see the lowest. I think it's 110. Yeah. So then I kind of just started at 100 and just went through to 200. Now, once you get that line numbered, you don't have to break anything because it just keeps going each way. So it would go with that same scale. So you would just number under there. Then you take this point, 120, and you put a dot above 120. So now I'm at 200. 170, 130, 150, 145, 140. When you occur again at 120, you put another dot above it. 125, 170, 120 again, 130, 120 again, 135, 110, 165, 140, 160, 150, 145, 180, 130, 130 again, 200. I think I already had that plotted a while ago, so I'm sorry. I marked that out if you put 200. I don't think 200 happened again, did it? Yes, it did. Maybe I didn't. Okay, because I see it right here. I was thinking I might have messed up. So there is a dot there. Okay, just kidding. So I got 135, 150, 135 again, 140, 120, and 140. Now, it's easy to mess up. That's why you want to kind of go back and count. So I'm going to go back and just double count mine in case I messed up. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 6, 7, 28, 29, 30. So that was there. Okay, so 2 dots. Okay, and then you would put whatever pattern you notice. You can see that it looks like that most of these patients' systolic blood pressure was falling in those areas. You can see this one occurred the most. This would be your lowest, and this would be your highest. That one's kind of a way outlier. So you can put down whatever you noticed because everybody notices different things. Now, the last thing I want to talk with you about, and I know these lectures are long with this, but it's a lot of information with all these graphs, and I want to make sure you understand it. If you remember, I hand wrote this one sheet for you guys that I asked you to also locate. So it looks something like that. So if you'll find that for a second, and we'll take a look at what I have written here, because you might feel like that you need to use some of that to help you. Okay, last time in the last lecture, if you recall, I told you to mark this part out because when you're dealing with that distribution, that was your table. The histogram is your bar graph. Okay, and then what we went to today, I spoke on this with you already. So the frequency polygon. So with the frequency polygon, remember that that needs to be closed. Okay, remember that that figure needs to be closed. Remember that you're going to connect the segments from left to right. So you're going to have to start at 0 and end at 0. Start at 0, end at 0. Your frequency, and I like to draw them like this with vertical and horizontal. Your frequency is your vertical. Your midpoints is your horizontal. And you're going to start at 0 and end at 0. Remember, it's got to be closed. Okay, going to this part with the ogive. The ogive is the one that is open. Okay. The ogive is open. Remember, with your ogive, you're going to go backwards one class. So when you do this ogive and you connect it, remember you have to go back one to put it on the x-axis. And this is your upper class boundaries. for the ogive. So remember, your horizontal is your upper class boundaries. Remember that your vertical is your frequency, your cumulative frequency. Because remember, it keeps adding. So you have to start at 0 and it keeps adding upward. And that's going to be your total frequency. Just like with the presidents being 30, that would be 30 where it would end at the top. Then we went to stem and leaf. Stem is going to be your left digit. Your leaf is going to be the right digit. Make sure that the numbers increase. Remember to include a key and show one data entry. For your double stem and leaf, you have 2 rows for each stem. You use the leaves 0 through 4 in the first stem row. In the second stem row, you use 5 through 9. So remember, you have double the stem, like double scoop of ice cream. Don't forget to include a key. Lastly, we did the dot plot. Each data entry is plotted using a point above a horizontal axis. If the data is repeated, then plot another point above the previous point. So remember, you're going to have a horizontal axis and you're going to put dots above. Now, just some key notes. Make sure your graphs have a title. Make sure you label your vertical and horizontal axis. Make sure you keep your scales consistent with an appropriate pattern. And make sure that you put a break if you need a break. Okay, so include that break if the pattern is repeating after the break. Okay, so remember, when you break that axis, it's kind of like that, and then it just continues. So if you start, it will say 20, and that next number is not 40. If it goes to 22 and then 24, you have to break it. You can even break the y-axis if it doesn't go in order, but most of the time the y's are going in order right now, but you might have to break them at some point. And don't forget to include a key for the stem and leaf. Okay, I have covered everything with you for this first test, so you need to be making sure that you're doing your homework and starting to get this information in your mind. And I will be giving you some assignments to practice. But all of the lectures have been taught for Unit 1 test. So your Unit 1 test, if you look back to your syllabus, it includes 1-1, 1-2, 1-3, 2-1, and 2-2. So that's your Unit 1 test. Make sure you upload these notes for today, and then you'll be having some practice assignments to study and start preparing for your test, and to finish up on 2-1 and 2-2, because you got to do the homework with that. Y'all did a good job with the homework from Chapter 1 that I've recorded. Make sure you check D2L for your grades to see how you're doing. And I'll start being more critical with late points now that everybody's getting the program. So make sure you're adhering to the deadlines. I hope you have a great day, and if you need me, let me know.